Hello and welcome to another lesson by Martin Tutorials. Today we're going to learn about pi. It's spelled P-I and they use the Greek letter pi, which is a math concept. I'm teaching it for beginners who've never learned about pi, just people in the street that say, oh, I know there's this math term called pi. I believe it's got to do with circles. What's it all about? That's what I'm going to teach today. To begin with, let's learn about proportionality because I'm going to use this to explain pi. You see, here we've got a photograph and that's the same photograph increased in size. This was taken about 15 years ago. That's me, and for those who live in the Greater Toronto area, that's Kevin Frankish of Breakfast Television. And another story is how do I end up having my picture next to him? That's another story, but I was honored to have my picture taken next to him. These two pictures are exactly the same, except one's a bigger size. Even though one is bigger, in relation to everything in the picture, everything's the same. So let's say, for example, in this building, let's say this window is the width is double that of the height. For example, over there, it would be double the height. Okay, let's just say this, we'll call him Mr. Photobomb. Let's say the height of his head is exactly 3.5 times smaller than the height of his head, just because of the location we're standing. In this picture, his head times 3.5 gives that head. In this picture, his head times 3.5 gives that head, because it's in proportion, everything increased together. And I'll just make up one more fun example. Let's say these two windows are exactly the same size. They will be exactly the same size in this picture because all increases together. Any comment we make about sizes in relation to each other will be the same in the next picture because they all grew together. It's the same concept with circles and with any shape. Let's pretend we even have a photograph of a circle and we keep changing its size. By the same concept, surely relative to each other, everything will stay the same, and it will. And the next question, the line through the middle of the circle. And I'm going to very quickly teach a little bit of vocabulary. The line through the center of the circle is called a diameter. And there's two words I can use for the outside of the circle. I can call it perimeter or I could call it circumference. Both are correct. And here's a good example. If I see a dog, I see a chihuahua walking on the street, I can call it a dog and I can call it a chihuahua. They're both correct. It's about context. A chihuahua is a type of dog. Same thing, perimeter is the outside of any shape. It could be a circle, it could be a square. It's the line forming the boundary. I could talk about the perimeter of a garden, a perimeter of a property, a perimeter of an unusual shape. Whereas circumference is the perimeter of a circle. Okay, and one definition of a circle is all the points that are the same distance from the center of that circle. Okay, so that's also called a circumference. The perimeter of a circle is specifically called a circumference. So a circumference is a type of a perimeter, but a perimeter is not always a circumference. It's the same way a chihuahua is always a dog, but a dog is not always a chihuahua. So if I get back to that, let's say we compare the length of the line, the diameter versus the line of the circumference. How many times bigger is the circumference compared to the diameter? If I go back to that, and based on what I explained on the previous picture with Mr. Frankish and myself, it makes no difference how big or small the circle is. Whether the circle's the size of the tip of your finger, or it's approximately the size of the solar system, or it's the size of Lake Ontario, or approximately the size of the sun, as long as it is a perfect circle, the relationship between the circumference and the diameter will always be the same. Now, of course, if I drew the circle, that's the antithesis of a perfect circle. That's why you don't get me to draw it to explain this concept. And that constant relationship, no matter what the size of the circle is called pi. And they use a Greek symbol pi, and it's the circumference divided by the diameter gives pi, or the other way around, the diameter times pi gives the circumference. And it's an irrational number. It cannot be written as an integer over integer like 5/7. As a decimal, the digits are 3.14159. That's how it begins, and then it just carries on forever. Okay, and the more digits you have, the more accurate. There's two fractions. 22/7 is a reasonable estimate. It's not exactly pi. And 355/113 is a more accurate estimate. It's not exactly, but it's more accurate. And the question is, given that the more digits you have, how many do you use? Well, let's think of real life when you're going to work something out. When you're starting arithmetic, if you're going to use it to, and I'm going to give some questions now to show. Let's say you're going to work out how much paint you need in a circular room. If you go over by a couple of grams, not here or there, it doesn't have to be perfectly accurate. If this is something is mathematical, let's say with NASA, and you're off by a drop, it's serious. Well, then you have to be very accurate. So it depends on the needs. Now, what I love about mathematics, I always say it is a tool for real life, for solving real life problems. That's why we use it. It's like a hammer or a chisel or a saw solves problems. Mathematics solves problems. Like what's the quickest route to go from A to B, or you want to build a bridge. How do you save money without compromising safety? You use mathematics. Which materials did you put in the bridge? Given there's certain material restrictions here and material restrictions there, you use mathematics. So here I've made up a question. Okay, we have a museum. One room is a perfect circle. We need to paint the walls. Okay, to decorate. This is a museum with a perfectly round room. We need to paint the walls and do other things to the circular wall around this room. Okay, but there's a problem. It's a huge circular room. It's very difficult in a big circular room. It's very difficult to measure a circular room. Like, how do you do it? You get someone to hold the measuring tape. So what we can do, instead of going around the circular room, we can measure the diameter, multiply by pi, and we'll get the circumference or the perimeter around this room. And we measure across and we get 11 meters. Great. So 11 times pi gets me the circumference, and it comes to 34.5575 meters. See, I've just used pi. Here's one example how we can use pi. A big circular room, it's very difficult to measure around in a circular room. We measure the diameter, multiply by pi, and we get the circumference, because it doesn't matter how big or small the circle is. If we take the diameter, multiply by pi, we get the perimeter or circumference, because it's the same ratio no matter how big or small the circle is. Now, this museum has another room that's circular, and it just so happens we already know the circumference from maybe a year ago we have it, but it's very difficult to measure across. Maybe there's things in the way and there's obstacles. We're told the circumference is 50.5 meters. What's the diameter across? Let's say we have to put something across the diameter we need to measure. Well, 50.5 divided by pi gives us 16.0746, and now we get the line across the circle, because it doesn't matter how big or small the circle is. The circumference is the diameter times pi, or the diameter is the circumference divided by pi. That's called proportionality. And that's lesson 1 about pi and why it's useful in the real world. Hope you all have a great day. Now to eat some pie. Well, I have to be careful. It's not too good for my diabetes. I'll find a sugarless pie.